simplifying exponents, using the properties of exponents to simplify them. So what are they? What do they do? How do we use them? Right? Everything we've been doing has been talking about simplifying it. First we talked about properties of numbers to simplify numbers. Then we talked a little bit about simplifying square roots, and then we got into simplifying like terms and variables, and now we're talking about simplifying exponents. Okay, a little bit of information about an exponent. Maybe it'll be review, otherwise if not, maybe write this down. Okay? For example, this is an exponent problem, a raised to n. The whole thing all together is called a power. And the whole thing is called a power. The a is the base. That is the number that we are multiplying, the number being multiplied. N is the exponent. That tells us the number of times that the base is multiplied. Okay? Let's look at 3 quick examples. Bing, bing, bing. Because the base is important. Here's your first example. Negative 2x to the third. Here, the whole negative 2 is being raised. This whole thing is the base. The exponent is 3. So this literally means negative 2 times x, negative 2 times x, negative 2x times negative 2x times negative 2x. Okay? Let's look at another one. Negative 2x to the third. The base is now just 2x, the exponent is 3. What this equals is a negative 1/5. The negative doesn't come with. It is not part of the base. The base, which is being multiplied 3 times, is 2x. Negative times 2x times 2x times 2x. Okay? The third example I'll show you is even stranger. Negative 2x to the third. Here, only the x is the base. So we have a negative 2 out in front, and then it's x times x times x. So be careful. Be careful as you identify the base. What is the base, so what is being multiplied? Okay, lots to keep in mind. Read the problem carefully. Keep an eye open for parentheses. The parentheses kind of clued us in as to what the base was. Watch for parentheses to tell you what the base is. Here, no parentheses, so x was the only thing being raised to the 3. The 2 is on the outside. That has to do with order of operations. It has to do with exponents then multiplying. Okay? A couple properties we need to talk about. Before we get into properties, anytime we talk about simplifying an exponent is fully simplified, or an expression with an exponent is fully simplified when there are no like terms, right? Like terms mean that you don't see x squared and x to the third next to each other. Bad. No negative exponents. Bad. So we're going to talk about how to simplify things. Before we do that, we talk about numbers raised to the 0th power. Any number raised to the 0th power is 1. X to the 0 is 1. 1 to the 0 is 1. 10,000 to the 0 is 1. Any number raised to the 0th power is 1. Okay? Except for 0. 0 to the 0th power is funky. We don't talk about that ever. It's ugly. Okay? Negative exponents. Okay? A negative exponent, how we're going to deal with it. I'm going to tell you how to deal with it first, and let's talk a little bit about what it is. To deal with it, we will draw a fraction bar and then we'll use it to move the entire power that has the negative exponent. Here's what I mean. Let's say you have a number x raised to a negative a. We first want to draw a fraction bar. That's a fraction bar, right? Numerator, denominator. You want to put this over 1. Put a fraction bar there too. Whenever you see something with a negative exponent, it means to move to the other side of the fraction. X to the negative a, when brought down below, becomes positive. And then in the numerator, since there's nothing there, we just put a 1. Have to move it from the top of the fraction to the bottom of the fraction, or vice versa, right? If we had 1 over x to the negative a, we bring that to the other side of the fraction. That now goes on top. Okay? And of course, we wouldn't actually write that. We would just write x to the a. Something to keep in mind is when you're dealing with a fraction, 3/5, the negative a, is the same as 5/3 to the positive a. Okay? So you may also want to watch out for or use reciprocals. Negative exponents are tricky, but treat them in terms of moving them around a fraction. If they're in the numerator, put them in the denominator. If they're in the denominator, put them in the numerator. Okay? Couple more properties. First one is product of powers. What that means is you are multiplying 2 powers. That x squared is x times x. X to the 4th is 4x's. Altogether, that's 6 of them. When you are doing these, you add the exponents. Right? 2 here, 2 plus 4 is 6. 2 x's plus 4 x's gives you your 6. Okay? Quotient of powers. Now you have x to the 10th over x to the 4th. You are dividing 2 powers. Well, that looks like x, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10x is in the numerator. 4x is in the denominator. I love when something is in the numerator and the denominator because we can cancel it. Look at that. Look at all that canceling. There are 6 x's remaining. X to the 6th. What did we do here? How do we go from 10 and 4 and get 6? Well, subtract the exponents. Okay, what about a power of a power? Okay, power of a power. So we're starting with x squared, and we're going to raise this power, this is a power, and we're going to raise it to the 3rd power. Well, this is what this literally means. It means that we have 3 x squareds, which really means xx, xx, xx. There are 6 x's. But look right here. 2 times 3 gives us the 6. If you have one power raised to another power, you multiply the exponents. That's what a power does. It tells you how many times to multiply. Well, here we're multiplying by 3, so multiply by 3. Okay? Some basic properties. They're pretty simple if you think about how we get them. How did we get to adding the exponents? Well, we started with 2 multiplied by 4, 2x's, 4x's, all together, 6x's. So if you think about where it comes from, it makes it easier to deal with. Okay? 2 more to talk about real quick. Power of a product or power of a quotient. Either way, what we do is we think about distributing the exponents. So let's talk about what that looks like. There's parentheses, or there's quotation marks on it, because it's a modified form of distributing. I want to show you what I mean. What we have is we have 6xy to the third. Just an example. Not 6xy to the third. You all know that these parentheses tell us the base is 6xy. 6xy is multiplied 3 times. That means that the 6th has been multiplied 3 times, the x is multiplied 3 times, and the y is multiplied 3 times. This 3, this cube, this exponent has been distributed to each one of the factors. Each part of the base is now raised to the 3rd power. Okay? Be careful. When we say distribute, we mean raise, distribute the power. Take everything inside to that power. This 6 to the 3rd is not 18, it's 216. Be careful as to what that means. Same thing we do with the quotient. This x to the 6th, x over 6 is raised to the 4th. That literally means x over 6 times x over 6 times x over 6 times x over 6. There are 4 x's being multiplied in the numerator. There are 4 6's being multiplied in the denominator. This 4 has been distributed inside those 2 groups. Okay? So be careful there. You're distributing, but you're distributing as a power. The number becomes a power for each of those other numbers. Okay? 5 examples I want you to try. Here they are. Oh, that's only 4. Time. 5 examples that I want you to try. Okay? Pause me. You attempt them first. Okay? You attempt first, and then we'll talk about them. Okay, let's see how you did. In that first one, we gotta do some multiplying. We have 2 times -5. That is -10. You do not add those. You add exponents. Those are just regular old coefficients. Kind of boring, actually. Then, dealing with those exponents, x squared, that's xx. X to the 3rd, that's xxx. 2 plus 3 is 5. There are 5 x's there. -10, x to the 5th. Okay? No multiplying needed in the second one. If you need to, write it all the way out. Y. Look at that. Look at all those y's. I love them. Cancel. Look what you have. X is the only thing left in the numerator. Y squared is the only thing left in the denominator. If you subtracted that 3 over 5, and you got y, 3 minus 5 equals negative y to the -2, that's great. But we can't have a negative exponent. We said that was bad. So we have to take that y to the -2 and move it to the denominator where it becomes positive. Anytime we move across the fraction bar, we change signs. Okay? 5x to the 6th raised to the 3rd power. We know we distribute that 3 in. Look at it, distributed here, distributed here. Okay? Here's what we need to think about. This 5x to the 6th to the 3rd is 5x to the 6th, 5x to the 6th, 5x to the 6th. 5 times 5 times 5 is 125. There are 6 x's, 6 x's, 6 x's, x to the 18th. Okay? X to the 18th. Holy macaroni, look at right here. Okay? First things first, whenever we see that negative exponent, we're going to draw a fraction bar. When you see the negative exponent, put that fraction bar down. And then you're going to start moving stuff. X to the 3rd stays in the numerator. Y squared stays in the numerator. On top, positive, on top. X to the -2 goes down below. Y to the 4th stays on top. Rewrite them. X to the 3rd up high. Y squared up high. Y to the 4th up high. X squared down below because it becomes positive there. Final answer, xy to the 6th. You have it from there. Okay, last one. Fraction bar's already there, so you're just going to start moving stuff.